For millennia, the night sky raised more questions than answers for humanity. Now, breakthroughs in space science are allowing us to peer into the cosmos and venture to unexplored worlds. New and wondrous views reveal the greatest mysteries of the universe. Epic discoveries, not only in our solar system, but in the far reaches of our galaxy. Cosmic vistas that change everything we know about space and life. The birth of the universe is perhaps the most profound mystery in cosmology. How and why did it come to be? What existed before, if anything? These questions have captured the imaginations of philosophers and poets, artists and astronomers throughout our history. Questions that we continue to investigate in the pursuit of new insights into how it all began.
Almost everyone is familiar with the Big Bang Theory that has the universe exploding into being billions of years ago. But the thing is, it's just a theory, though widely accepted. We don't really know how or why the Big Bang happened, which means we don't really know why any of this exists.
Was there something before the Big Bang? Was it another universe, or just an energy field?
And after the Big Bang, how did particles and atoms, stars and galaxies, and even biological life like us begin to form?
To investigate the evolution of the universe, cosmologists must gain new insights and reevaluate previous theories into the formation of stars and galaxies. When the universe was far younger than it is now, millions, if not billions of years ago.
We need to study the universe of the past. It's like looking at ancient ruins to see how civilization has progressed from the ancient past up to today. Call it cosmic archaeology. And to do that, we need to observe relics from the cosmic past.
The thing is, there's no way to effectively study these objects from Earth. They were created so long ago with the universe expanding that they're really far away. And there's a lot of cosmic stuff in between. Celestial objects, dust, gases. And to make matters worse, our own atmosphere acts like a distorting lens, making it even trickier.
To discover more about the ancient cosmos and how the stars, galaxies, and planets within the universe have evolved over time, a new generation of highly advanced deep space telescopes have been developed. NASA's James Webb Space Telescope launched in 2021.
Webb is the most powerful telescope of its kind ever made. The Hubble Space Telescope has been up there since 1990, but Webb can see over 100 times further.
The engineering behind this is jaw-dropping. It's origami on a large scale in space. The last component to deploy are the wings of Webb's primary mirror. This is basically the eye or lens of the telescope, a highly polished mosaic of mirrors designed to collect infrared light, which will later be processed into images.
Webb is truly a unique machine, but it won't be out there all alone, because just over a year later, another remarkable space telescope arrives in the same neighborhood, so to speak.
This is a European Space Agency-led mission, and the telescope is called Euclid.
Although smaller in size than Webb, Euclid has a more powerful optic system. It's one of the largest cameras ever flown in space. Euclid is small but mighty.
Traveling over 1 million kilometers from Earth, both telescopes are tasked with observing ancient celestial bodies that are so old they may no longer exist.
If that sounds like they're seeing back in time, that's because they literally are. How is that possible? That's the nature of light.
Light takes a specific amount of time to travel through space, almost 300,000 kilometers per second. Light from the sun takes 8 minutes and 20 seconds to reach the Earth. So we see any light-emitting object as it was when it emitted that light. For example, the Andromeda Galaxy. It's 2.5 million light years away, which means we are seeing it as it looked 2.5 million years ago. We are literally looking back in time whenever we look at anything in the universe that emits light.
That includes the most familiar celestial objects, the stars and galaxies. But these didn't just appear out of nowhere. The Big Bang didn't create them in an instant, but instead, they evolved over time out of gases and dust. And this is one of the mysteries that astronomers are trying to unlock, to peer deep into the past to see the first stars emerge and group into galaxies.
To gain new insights into how the universe formed, we must study what is called the Cosmic Dawn, an era that spanned 50 million to 1 billion years after the Big Bang, a time when the young universe effectively turned on, and the first stars began to form and cluster into the first galaxies.
We know very little about the Cosmic Dawn period. It's a huge gap in our knowledge of the universe and how it evolved after the Big Bang. Why exactly did this first light happen?
As well as studying the birth and evolution of the cosmos, by observing its distant past, scientists are hoping the Webb and Euclid space telescopes will be able to shed light on another fundamental question.
The universe is expanding, but we don't know why. We know it's expanding because everything we observe in space appears to be rushing away from everything else. Take this balloon. Here are the stars and galaxies in the universe. When I blow it up, the distance between them increases. This is basically what we see when we look at the universe. But what will happen in the future? Will it continue to expand forever? Or will it eventually collapse? Through the force of gravity in what some scientists call a big crunch. How will the universe end? We just don't know.
In January 2022, Webb arrived at its orbital path between the Sun and the Earth. 1 year later, Euclid arrived at its own orbit. Both of these telescopes promised to deliver new insights and images of the universe that are unprecedented in detail and clarity.
Euclid uses its advanced optics to survey and capture thousands of images across immense areas of the cosmos and put them together as a mosaic. All of the images will be included in a fantastically detailed 3D map.
When this map is finished, it will be the largest, most interactive, and detailed map of the universe ever made. Because it is looking back into the early universe, Euclid is basically making a map of cosmic history. There has never been anything like it, and Euclid will be a crucial tool to understand the young universe.
So while Euclid and Webb are separate missions, they're really complementary. By focusing on the different periods in the early universe, and the different phenomena we can see, it gives cosmologists data to compare and perhaps to answer some of the big questions in cosmology.
Webb and Euclid work primarily by taking pictures of the ancient cosmos. In 2022, Webb beamed back the first images to Earth, dubbed Webb's first deep field. The highest resolution infrared image of the universe ever captured. This single frame contains thousands of galaxies, some as old as 13 billion years.
One of the most striking things about this image is just how tiny that patch of sky actually is. NASA compares it to a grain of sand held at arm's length by an observer on the ground. And yet it contains cosmic multitudes. It's an awe-inspiring reminder of our universe's immensity.
Webb has found the oldest and most distant galaxies ever formed. Webb has also revealed that stars in the early universe form extremely quickly, way more quickly than our models expected, and also that they form in massive stellar clusters. There are just way more stars than we expected.
So we now have to rethink how stars and galaxies formed in the cosmic dawn and how they've evolved since that time.
Next came Euclid's first images. These were stunning.
Euclid's image of the Perseus cluster has yielded fascinating and conclusive science, including faint galaxies that were previously undetected. Perseus is one of the most massive structures ever discovered in the universe.
These space telescopes are revolutionizing our understanding of the cosmos. The striking images of Perseus, containing thousands of galaxies immersed in an immense cloud of gas and cosmic dust, provide scientists with more evidence that there is, in fact, a galactic energy we cannot detect. An invisible gravitational force that has enormous influence over the astronomical bodies we can detect, such as stars, planets, and moons. We call this substance dark matter.
It doesn't emit or interact with light, and that's why we call it dark. We recognize and can measure its influence on regular matter, even though we don't know what it is.
Dark energy and dark matter are known collectively as, wait for it, the dark universe. They are so prevalent that we now think that they account for about 95% of everything that exists.
That means ordinary matter, atoms, me, you, mountains, planets, stars, is only 5% of what's in the universe. Think about that. That's mind-blowing, but it's also humbling.
Thanks to Euclid, scientists can say conclusively that clusters like Perseus can only form if dark matter exists to bind them together.
Euclid is sending back so much information that we're using AI and citizen scientists to help organize and analyze it all. A single batch of images captured 380,000 galaxies, some as far as 10.5 billion light years away.
You just can't overstate how these telescopes are revolutionizing our understanding of the cosmos. It seems almost every week we get a new image and these are revelations.
The deep space missions of James Webb and Euclid are giving scientists incredible new insights into the early universe and how stars and galaxies formed since the cosmic dawn. And we are learning more about the invisible and mysterious forces that may bind the cosmos together.
These are essential missions in space sciences and will be feeders of knowledge for generations of scientists, cosmologists, and researchers, an incalculably valuable legacy.
Euclid's mission finishes its survey of the solar system in 2029, while Webb is expected to operate into the 2040s.
Who knows what they'll discover next? Maybe they'll reveal why the Big Bang happened. Maybe even how the universe is fated to end, billions and billions of years from now.
A new generation of space telescopes is dramatically altering our knowledge and offering new perspectives on the very fabric of the universe and the dark and invisible forces that influence its continual growth. But while we are accustomed to thinking of our own planet as one of many in the solar system, it was only relatively recently that we first saw this striking image of our planet from space. And that vision gave entirely new insights to life on Earth. Throughout history, humanity has shared an inherent trait to explore new frontiers, and in doing so, learn more about our own planet. This curiosity to better understand our own place in the cosmos has propelled us to reach into space itself. That crucial breakthrough came in 1968 with the Apollo 8 space mission. On Christmas Eve, when the crew got into orbit around the moon, the astronauts witnessed an extraordinary cosmic vista. Planet Earth itself.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, that pretty.
It was the first time that anyone had ever seen Earth rise. This was the Earth coming over the horizon of the moon, much like we see the sun coming up over the horizon of the Earth. And the images that the crew captured would change our perspective in how we understand our planet forever.
They were looking down at the Earth from the moon's orbit because the US was locked in a space race against the Soviet Union. And that space race was just an extension of an arms race, because the same rockets that launched the Apollo missions and every NASA mission just evolved from rockets that were meant to carry weapons.
NASA's pioneer of aerospace engineering and its chief rocket scientist was Wernher von Braun. During the Second World War, he helped develop groundbreaking new rocket technology for Hitler's Nazi Germany.
When the war was over, the U.S. military nabbed German rocket scientists like von Braun, brought them to the U.S., and put them to work against their emerging enemy, the Soviet Union. They also strapped a camera to one of von Braun's V-2s and shot it into the atmosphere.
The rotation of the rocket causes the planet to spin before the lens, and the camera photographs the Earth 65 miles straight down. The horizon, 720 miles away, and the curvature of the Earth are astonishingly apparent in this still picture from the film.
So we knew we could launch a rocket into space. We'd strap a camera to a V2, so maybe we could strap something else to these rockets, like a satellite. In principle, we knew it was possible, and the Soviets did it first.
October 4, 1957, when Sputnik, the first Earth satellite, was launched. In the history of the Earth, no other event had captured the imagination of so many people as this first step into space.
America was way behind the Soviet Union in terms of getting to space. And a month later, the Soviet Union did it again. And this time, they sent the first living organism to space. It wasn't a human, it was a dog.
Laika, first space traveler, was ready for the takeoff.
1 month after Laika was sent into orbit aboard Sputnik 2, the U.S. space program prepared to launch its first satellite into orbit. Dubbed the Vanguard TV-3, it was designed to assess rocket launch capabilities and was carrying electronics to study the Earth's atmosphere whilst in orbit. But American scientists would learn a valuable lesson: that space exploration can be full of setbacks.
America's prestige had never been lower.
By 1961, 3.5 years after the Soviet Union launched Sputnik 1, there were over 100 satellites orbiting Earth. Satellite technology was rapidly advancing into powerful observational tools designed to monitor Earth itself.
Satellites opened up a whole new world of strategic defense planning. Rival nations could keep track of each other's troop movements, detect missile bases under construction, even detect nuclear tests. All of this was basically untouchable espionage.
Observing the Earth for intelligence and defense purposes fundamentally changed geopolitics. And that continual game of one-upmanship just went from the battlefield right up into space.
There are more reconnaissance satellites in orbit than ever before. They're clandestine, so it's hard to know the exact number, but it's estimated that there's probably hundreds of them up there. Someone is always watching.
While satellites had been launched by nations to spy on each other for decades, that very same technology is used for the greater good and has given us new insights into the changing conditions of life on Earth.
We don't stop to think about it very often, but we rely on satellites for two basic things: weather predictions and food. It's easy to forget that before we had these instruments, we had no way of knowing that a hurricane or a tropical storm was brewing offshore. We couldn't predict or monitor wildfires with any precision or accuracy, but now we can do all of these things because we can see our planet from above in detail. We also do all sorts of atmospheric tracking for carbon dioxide measurements that have a big impact on the heating and cooling at the surface of our Earth.
So satellites are fundamental to our lives, even though we don't notice it most of the time. And they play key roles in all sorts of science. For example, we can track penguin colonies by following their trails of guano, and satellite archaeology has revolutionized our understanding of ancient civilizations in the Amazon.
The Landsat satellite program that's been continuously monitoring the surface of the Earth since the 1970s, it's actually able to examine changes in land use and pinpoint where there could be problems. And so really, using imagery and data taken from space allows us to save lives on Earth.
While more and more satellites were being launched into Earth's orbit, nations were now developing innovative designs for unmanned space probes to travel far beyond Earth and into our solar system. In 1977, NASA launched Voyager 1. Tasked with studying the distant planets of Jupiter and Saturn and observing their atmospheres, weather patterns, and magnetic fields. Far from home and never to return, it looked back and captured one of the most poignant images ever taken from space.
Voyager 1 was over 6 billion kilometers from Earth, beyond the farthest planet in our solar system, Neptune, when NASA instructed it to take one final set of photographs.
These weren't just spontaneous snapshots. The team had been planning these images for 9 years to send us a message, to put humanity into perspective, much like the Apollo 8 Earthrise images did.
In one of these images, barely visible, is a pixel of light, a tiny solitary speck within the immeasurable vastness of the universe. This seemingly insignificant granule is planet Earth itself.
The pale blue dot. That's what cosmologist Carl Sagan called it. He was part of the Voyager mission.
When I look at the pale blue dot image, it reminds me just how small the Earth is in the grand scale of the solar system. And so, even though we feel special when we can see ourselves close up, I think the pale blue dot image really helps hammer home the idea that we're just a speck of dust in the cosmos.
Images of Earth taken from space are today ubiquitous. Almost everyone has seen photographs of our planet from above. But what do the people who have traveled to space and orbited Earth actually experience when they witness that vision? Of the small number of people who have been to space, almost everyone reports a feeling of profound well-being and awe, but also of vulnerability. This experience has a name. It's called the overview effect.
There's no words to come close to the ever-changing picture that I see staring at this planet.
It hits you when you first look at Earth, and it's literally a cognitive shift, and it's almost like this transcendence of your senses. And then you look out in the other direction, it's just black. And all you can imagine is the universe is just endless.
As technology advances, and it's moving at a breakneck speed, more people will get the opportunity to see our home from space. If everyone could see that view, not just from a picture, but for real, maybe things would change for the better down here.
The evolution of human space travel is at a new juncture. From space tourism to the prospect of inhabiting other planets in our solar system. One key mission that led to this point came in 1990 with the launch of NASA's robotic space probe, Galileo. Its mission was to closely observe Jupiter's atmosphere and its moons. But to make that long journey, it had to circle back after launch and use Earth's gravity to propel it in the right direction.
Scientists on the team used this as an opportunity to turn on their instruments and actually take measurements of Earth. And what they detected was signs of oxygen and methane in the atmosphere, along with radio signals that were being transmitted. So really what this was is a proof of concept that spacecraft instruments can be used to detect signs of life on other planets.
The idea is to use Earth as a control in our search for extraterrestrial life. So whether we use space-based telescopes or space probes, we compare data we have about life here on Earth with data we collect about planets outside of our solar system, the exoplanets. So not only are we learning more about our planet, we're also developing a model that will help us understand other planets and their suitability for life.
While we search for possible sustainable habitats on other planets that might harbor life, we are venturing forever further, gaining new insights to the far outer limits of our solar system. we are now exploring an area of deep space we know very little about. A distant and mysterious frozen domain that could change our perceptions of how planets might have formed over time. Billions of kilometers from the sun is a new frontier. Beyond the ice giants Uranus and Neptune lies a mysterious dark realm. Since the early 20th century, astronomers offered various theories to the existence of a possible large comet belt, or hypothetical uncharted planets and moons. And since then, scientists have yearned for a closer look, to gain new insights into this strange, distant domain at the far reaches of our solar system.
We discovered a large donut-shaped disk of objects orbiting out beyond Neptune that contains billions of celestial bodies. Because these objects are mostly cold and very small, they don't reflect very much light. We call this the Kuiper Belt.
It's hard to overstate just how enormous the Kuiper Belt is. It starts just beyond Neptune's orbit, and it stretches more than 3 billion kilometers from the inside of the ring to the outside of it. That's 20 times the distance from the Earth to the Sun.
To learn more about this strange, distant realm, sometimes referred to as the third zone of the solar system, NASA launched the space probe New Horizons in 2006. Its mission was to chart and explore this unfamiliar domain, looking for more evidence of the objects we knew about, and search for others on which we had merely speculated.
Why do we want to explore the Kuiper Belt? Because Kuiper Belt objects are the leftover material from the very beginning of the solar system. They've barely changed at all since 4.6 billion years ago. So if we want to understand how our solar system evolved, that's the place to look.
This is a region of rocky, icy objects. So far, we've cataloged some 2,000 of them, but we estimate that there are hundreds of thousands that are 100 kilometers in diameter or bigger, and possibly trillions of smaller ones. We call them Kuiper Belt objects, or KBOs.
The KBOs would have formed a planet, or planets, had Neptune not been there. Neptune's enormous gravitational influence is what scatters them or prevents them from forming something stable. In the inner Kuiper Belt, Neptune has kept them scattered and chaotic in their orbits.
Unlike asteroids that are largely formed of rock and various metallic minerals, many Kuiper Belt objects are composed of a combination of rock, water, ice, and compounds, including methane and ammonia. But within this strange, vast ring of frozen objects, astronomers have long speculated as to the existence of something much larger, an undiscovered superplanet.
There might actually be a planet lurking out there in the Kuiper Belt that we've never detected. A big planet, maybe 10 times the mass of Earth. It's sometimes called Planet X.
If we do find Planet X, it will fill a gap, so to speak, in our solar system. Most planetary systems out there seem to have a super Earth. That's a planet bigger than Earth, but smaller than Neptune. There's no such planet in our solar system, unless it's Planet X.
The search for a hypothetical Planet X has tantalized astronomers since the 19th century as a means to explain the confusing discrepancies in the orbits of Uranus and Neptune. The presence of a larger object, like Planet X, would explain a gravitational influence over its smaller neighbors. In 1930, Clyde Tombaugh, an American astronomer at Lowell Observatory in Arizona, was searching for Planet X when he discovered Pluto. Because it was so remote and so cold, it was suggested that the new discovery be named after the Roman god of the underworld. It then became the 9th planet in our solar system.
For the next 62 years, that's about all we had, a name. We didn't know how big it was. We didn't know what it was made of. We didn't know anything about it. We did not even know what color Pluto was.
One of the goals of the New Horizons mission was to get up close to Pluto, one of the least understood celestial bodies within the vast Kuiper Belt. And even though it is part of our solar system, Pluto is over 5 billion kilometers from Earth, and it would take New Horizons 9 long years to arrive in its orbit.
For a long time, we called Pluto a planet. Many people still do. But here's the thing. In 2006, ironically the same year that New Horizons launched, the astronomical community decided that Pluto wasn't a planet after all.
The Astronomers Union offered a new perspective in regards to Pluto when it passed a vote, redefining the criteria of what a planet is.
According to the current Astronomers Union definition, a planet must, 1, orbit a star. Pluto obviously orbits the sun, and so check. 2, must have enough mass that its gravity squishes it into a spherical object. Once again, check. And 3, it must be big enough that its gravity has cleared its orbit of other objects of similar size. And that's the problem. Pluto shares its orbit with other Kuiper Belt objects, which means it doesn't meet this new definition of a planet.
This was extremely controversial. Mike Brown, the astronomer who proposed the term dwarf planet, got hate mail. People were emotional about a rock in space. It's interesting how people get so attached to the way they understand the world. To them, losing Pluto as a planet felt almost like losing your dog.
Despite reclassification as a dwarf planet, we knew so little about Pluto. The New Horizons space probe was traveling for 9 years through deep space to take high-definition pictures and conduct analysis. Information that could dramatically shift our insights of this frozen entity within the Kuiper Belt and how it might have evolved since the formation of the solar system.
Until New Horizons came along, the best images we had of Pluto were blurry ones taken by the Hubble Space Telescope. But New Horizons, with its super high-resolution cameras, was able to get close-ups of Pluto.
These are the sharpest images ever taken of Pluto.
It's gone from a white, bland ball to incredibly detailed and informative.
Once we saw Pluto, we realized that demotion, that debate, none of it mattered. This was an amazing place. It's the largest object in the Kuiper Belt. And it made no difference at all whether you called it a planet or a dwarf planet or anything else.
It has a range of subtle, beautiful colors.
There are geographical features we weren't expecting at all.
Strange, scaly formations.
Ice mountains surrounded by rippling plains.
That huge, heart-shaped, bright region? That's actually a glacier made mostly of nitrogen. It's 1,000 kilometers wide. It's the largest known glacier in the solar system, and it's active, meaning the ice is being renewed.
This glacier could be less than 10 million years old. That may seem a long time to you and me, but by astronomical standards, that's very young. So much of the surface of Pluto is far younger than previously estimated.
Analysis also revealed that Pluto possessed a thin atmosphere, composed mostly of nitrogen, methane, and carbon monoxide, with an average temperature of -197 degrees Celsius.
What New Horizons discovered in one fell swoop has completely revolutionized our understanding of Pluto. The data these images contain is still keeping us busy many years later.
It was an amazing opening act for New Horizons because Pluto was only its first stop in the Kuiper Belt. New Horizons had another destination.
In 2019, 13 years after its launch into deep space to explore the distant edges of our solar system, the New Horizons space probe investigated a strange object within the vast ring of the Kuiper Belt. One of billions of celestial bodies left over from the birth of our solar system, the findings would challenge our theories about how planets formed millions of years after the cosmic dawn.
It's called Arrokoth.
In the language of the Powhatan people, whose traditional territory includes the headquarters of the New Horizons team in Maryland, Arrokoth means sky.
Arrokoth is the most distant object that we've ever explored up close. New Horizons takes an intensive series of observations, including photographs in different wavelengths, to study its shape, topography, anything it could grab. And what it finds is a bizarre object.
It looks like a rusty, squashed snowman.
Its shape, those two lobes, suggest that the early solar system may have been formed by slow speed collisions. Think walking speed. If objects collide at high velocity, they smash to bits, don't have a chance to merge and gather material to form planets. So perhaps the solar system was formed the same way it looks like Arrokoth, which is a slow collision which allowed the two lobes to merge.
This is important because it challenges the prevailing theory of planetary formation, which is a much more violent affair involving grains of space dust colliding with increasing force, growing into larger and larger objects until they become planets.
We think of Arrokoth as an unevolved object because it hasn't changed very much since this first formation. It is therefore not just a very distant object, but also a very primitive one.
It just goes to show you that even a quick flyby past a small object like Arrokoth can lead to new information, causing us to re-question our hypotheses and models of planetary formation. But that's what good science is. Always self-correcting and re-evaluating.
After the Arrokoth flyby, New Horizons travels deeper into the Kuiper Belt in search of new discoveries. Deeper into the unknown.
Pluto and Arrokoth were great successes for New Horizons, but we're really just getting started in the exploration of this region of the solar system.
New Horizons discovered something unexpected. Levels of dust high enough to suggest there might be a second Kuiper Belt intersecting the one that we know about. That would be wild.
What's next for New Horizons? While Earth and space-based telescopes are looking for new candidate destinations, New Horizons is maintaining its trajectory in the Kuiper Belt.
New Horizons is expected to stay operational into the 2040s, after which it'll become one of only a handful of other spacecraft to leave our solar system. Until then, what else will it discover in the expanse of the Kuiper Belt and outer solar system?
The most powerful space telescopes ever built have fundamentally changed how we understand cosmic history. Satellites and human space exploration remind us that our planet is a fragile dot in the vastness of space. And deep space missions to the outer limits of our solar system are revealing unexpected surprises, causing us to reevaluate theories of how planets might have formed. But for as long as we have looked up at the vast majesty of the night sky, we have continued to ask some of the oldest questions. How did this all come to exist? How does it change and evolve? And does it even end? For as long as we are here, we will continue in our search for for new insights.